Hi and welcome to my shop, and thanks so much for joining me here with this gigantic radio I have in front of me. So it's November 6th and I just finished a radio very similar to this one. In fact, it's still sitting here in my shop because I don't know what to do with it. It's so big. I haven't found a spot in our house or anybody else's house for that matter. And lo and behold, I was so impressed by that other radio because of the somewhat unusual dial face. Turns out, well, maybe it's not so unusual, I just haven't seen them. Here's another one with these very fantastic dial face here. What's fantastic about it is you see all the light bulbs here. So as you switch bands, the radio highlights only the band you've got operating, which is something I had never seen before till the last radio. This is an older version of it, though. I'm pretty sure this is older. Now, older and bigger. So I don't know anything about this. I don't have the speaker that came with it, but I think I can probably use the speaker from the other radio on it when we get to that phase. So this is a replaced wire. See, it's not strain relieved, at least. Push it in. Strain relieved on the way out. Has a magic eye, which for some reason, I guess this is mounted in the cabinet like this, I guess, something like that probably. Put it back here. The capacitor is a three section capacitor, tuning capacitor. This looks like the speaker plug. Is it not on the back? No, it's not. The speaker input is right here. Right by a, let's see, this is a big rectifier tube. This looks like a number 80 to me. What is this? 5Y3? What is it? I don't see a number on it anywhere. Yeah. Okay, not sure what it is. Looks like a full wave rectifier. Great big transformer here. This has got to be the output tube here. Let's just pop it out and take a look at it. This is probably a 6F6. 6L6. Ooh, a 6L6. Metal. Wow. Okay. That's something. Okay. 6L6 is kind of a special output tube, if you like. Okay, that's it all the way. Unusual flange on the base here. Another tube here. Things I'm noticing already. So you can see the wire coming up here. See, the insulation is just completely shot. This is a green colored wire, and my experience of this vintage of radio with green colored wires is this is what happens to them. So if I move this, which I will eventually have to do, I'm sure, the rest or much more of this is just going to flake off. Yeah, up here in the air it doesn't really matter, but see where it's going through the chassis. Looks like it has a rubber grommet there. Well, I guess it's rubber. It doesn't feel very rubbery now. Look, there's another tuning section here. I had noticed that. There's actually 4 of them up here. A little tiny one there. What is that for? Okay. 2 big filter capacitors here. Big physically. 10 microfarads. Positive, negative. This huge thing for 10 microfarads? Really? And another one here. This one is also 10. So that's a typical capacitor size for a radio like this, with a big transformer and a field coil in the speaker. Excuse me, I mentioned I don't have the speaker, but I'm sure it's a field coil speaker. Or these would be much larger. And in this vintage of radio, they're almost always talking about field coil speakers. Let's go around the other side here. A couple IF cans here. I have another one here. Well, they may not all be IF. They may be some front end antenna coil transformer or something like that. More green wire here, more green wire here. Look, it has a plate here. It's on a funny angle too. Well, that's got to be shielding this tube from this tube, I would think. That's what that is. This is a metal tube, this is a metal tube, so why the shielding? I guess we could guess originally they weren't metal. This cracked wire here is, whoops, my hand's in the way, right here. It looks like it's shorting against the chassis. This one right here. So we're going to have this kind of problem all over the place in this radio. This one's got a rubber, this one had a rubber grommet, but these other two don't. We have a ground terminal here. Okay, so there's a metal strap that comes to the rivet, and the rivet is on this bracket which is riveted to the radio. So this is the ground, here's the antenna. Hey, look at this. I meant to mention this. So someone's already tried to do something about the wire up here. Yeah, wow. And here too. Of course, this doesn't really matter because there's nothing up here. You can have a bare wire there if you really wanted to. Pretty sparse up on top considering all the real estate that's up here. And I've got these plunging type capacitors here that this shaft goes up and down to vary the capacitance. There's one here, one here, one here, one here. And any other adjustments from the top? Doesn't really look like it. Okay, we've got a H6 tube here. This is the, I think this is the detector. Will be the detector. 6J5. Maybe RF amplifier, I'm not sure. A lot of tubes in here. A lot of tubes. A lot of tubes. So the antenna is coming in here. So you kind of imagine that this is the start of the radio. This might be an RF amplifier. I could guess away, but what's the use? Oddly enough, here's a paper capacitor here, a cardboard tube type capacitor as opposed to the metal ones over here. That's a little unusual to see on a radio this old. Let's see what we can read on that. 450 volts, 20 microfarad. Something, I can't quite read that. Lots of writing on it anyway. Positive, red, negative is black, and it's a 20 for 450. Well, anything else up here that I haven't spotted yet that I should really spot? We can look at the gigantic wheel and see somebody's initials written right here. A little hard to see in the camera. Somebody wrote in pencil MW. It's probably the guy who built this. Probably wrote his name on it. Who built this as a subassembly in the factory. MW. Yeah, it just sounds like initials to me. Lots of dirt built up in here, whereas the dirt is largely removed here, which indicates someone's been reaching in periodically with the radio in the cabinet and removing as much dust as they can. But there's lots more to go here. See the gear driven tuning, and there looks like there's, yeah, this is the anti-backlash system, where it looks like I'm pointing at one large gear there, but that's actually two identical gears pushed together like this. Like this. And then there's a spring pushing one this way. And so when it engages with the other gear, you know, with the drive gear here, the drive gear pushes against the spring and separates these back to make space for its gears to go in. And in this way, this gear is pinching the other gear all the time. It's grabbing on those. There's none of this. Okay, none of this, because that gear has two gears, and every gear tooth is two gear teeth It's a really terrible explanation, but in any case, the whole objective is to make sure you don't have this when you're tuning, or you're going to go nuts. You want this. You want this thing to be locked up tight, so as you turn the knob, you turn the wheel. It's a huge, huge wheel on this. String looks very good. This is a heavy duty design here. How they've done this. This is, you know, most radios, this amounts to just a flat piece of steel and a thing sliding on it. Look at this. What a rig. What a rig. Holy smokes. So I guess, you know, in the process of design evolution, you're constantly making things smaller, lighter, cheaper, simpler. So if you look at early technology, you're liable to find it in many ways more complicated than later versions of the same thing. Well, let's try tuning it. Let's try finding the tuning knob. This must be the tuning knob here. There we are. So this is a really very unusual. I got to get a different camera. We're going to take a look down in here more closely, because this is just a little bit unusual. It's not like the other radio. This is my close-up. What I call my close-up camera. This is just another camera. Here we go. A little more light. So what do we got happening here? We got springs galore. So there's this. Oh, look at that. That's a copper cable. Where would that be going? Is this whole thing a copper cable? It comes up on the wheel. Oh yeah, it's not a string. Remember what I said about things being expensive in the early days? Look at that. It looks like an elevator cable. Is that really a cable? Yep. Wow, no string here. So is that the same cable here? I thought this looked like a wide band to me. Oh, it's two cables, side by side. A spring in behind there with some. What is going on here? So this is obviously a switch here. I can't see this at all from standing in front of the radio. You gotta get down and look under. What are they doing exactly? So I probably can't work anything here because. So I can turn the tuning, no problem. What's happening back there? String was overlapping there. Oop. That was a bad sound. There's a knot back there on the far way in the background. I can see a knot. Now, it's not typical to put a knot in a spot like that. That does not look like a factory original or anything like that. I think. Now wait, this is string. Where'd the copper cable go? So this string we're looking at now. Looks like it's just going up and around that. A double string, two string, a double. No, it's only one knot. Same string going around twice. Like a double wrap. That's what it looks like. Well, I've never seen that done before. They use two strings. And what's it turning up there? It's turning. Oh, it's turning the tuning. Is it? That's what's driving the tuning? So the strings are coming up. This is tricky from back here. The strings are coming up. There they are on that wheel. That wheel. Isn't that funny? One goes one way and one goes the other. So the shafts, yeah, there's a big hole for the shaft to go through. Yeah, yeah. Big slot, in fact. Great big slot. So the string is driving the capacitor through this gear arrangement here. This is fairly hard to. There, can you look on the big wheel? Gear. You can see the two springs kind of inserted right inside the wheel. So that's the springs that are affecting that gripping action that I was talking about, which occurs right down in here, giving you zero backlash. So there's never any play here. Except the string. The string, inevitably strings have a little bit of stretch to them. You can't really see it there. So your actual original drive is with string. Heavy duty double string. It's not particularly locked. Oh, that's the same knot, I think, just coming around. Oh, this knot goes around and around. You can't help but have this knot come over. Did it come over on the same side? Okay, reach the end of the row. Let's go back. Okay, knots on the right side. On the right string. Oh, did you see the strings rotate? And it shows up on the right side again, but it's actually on the other string now. All the same string. I think you know what I mean, though. So a rather complicated mechanism here for tuning. Now, what's the big steel thing doing? So there's a copper thing, as you can see on the outside of the big wheel. Wow, look how they did that. No springiness there. Where's the springiness? Is that on the other side? Does that copper get... Yeah, here's the copper. Yes, so there's the copper spring. Oh, wow, this is like elevator quality cable work here. Holy smokes. And so this must be the pointer driver, which is coming way up here on top of the radio. Why they chose to do that? Well, I think it comes back to what I was saying about maybe a little over-engineering. Surely this wire is much more expensive than the string, but maybe it's this. It's very, very long, which means a tiny percentage of expansion would cause a big problem here. As much as you can have a big problem in an old radio. So maybe they opted for this wire because it has zero stretch. And there's a lot of it. Okay, I like to dwell at this point. Anybody knows that? Because by dwelling, you find things you don't expect to find. 19-meter band, Moscow, Berlin. Bandung, never heard of that place in Java. Any other cities that... Eindhoven, never heard of it. Schenectady, really? Schenectady was important back then? Yeah, could be. Mexico City, who else is here? Pittsburgh. Lots happening in Pennsylvania today. Boston. Where's Toronto? No, you know what? Oh, Winnipeg. Winnipeg made it. But, Toronto never makes it on these. Now I'm going to find it soon. Winnipeg. Winnipeg. And this is the broadcast band. With beautiful blue, green, red, lovely colors on this thing. Get this lit up nice, it's going to look pretty cool. What's that down there? Buenos Aires, Berlin, Cartagena. I think I've heard of Cartagena. Schenectady again. Rio de Janeiro, Madrid. It could be like a thrill back in the day tuning through this and picking these stations up. Goodness knows if these things were ever accurate. Because the transmitters move around a little bit, time of year and over the years. So you know just how long this would be true that you could find Guatemala City there. I don't know, but you know every radio has these written on it. Mexico, Havana, Berlin, Boston, Cincinnati, Toronto. There it is, twice. Toronto twice. Could be that they put all these cities on here because they know they're going to try to sell a radio in these cities, in North America anyway, and you want your city on here. So how come Aurelia doesn't appear? Trujillo, La Ciaba, never heard of them. Well, okay, that's interesting. Journey through the tour, or journey through the tour, journey through the dial here. I just get it straight now. What do we got? We got 5 bands because there's 5 lights. The broadcast band right in the middle of the whole thing. And do we have a general shortwave band? Do we have a general? Well, the other radio has a general shortwave band, so this goes from 6 to 6.2. So that's band spread. These are all band spread. 49 meter band spread, 31 meter band spread, 25 meter, 19 meter. This is a the other radio, instead of having one of these bands, it has a general band stretching all the way from 6 to 18 megahertz or something, but not this one. That would make this just a little bit of a better radio in a sense. Very clean looking. Like the print doesn't look right. To me, the print looks like 1990s style print. Doesn't have that old look to it. But you know, these things, as old as they are today, when they were coming out, these were hot technologies. Hey, well, I got this light in my hand, or camera in my hand rather. Let's just poke around here a little closer. Oh, looks fine. How are these wires? So these never get moved, so they're probably in just perfectly fine shape. How stiff are they? Let me pick one. Oh yeah, you bend this at all, it's going to crack. It's as stiff as can be. So we should look. Well, okay. So here's one of the green wires I was talking about earlier. You know that's going down under the radio. Goodness knows what's happening under there. Again, these things don't get moved? Yes, they do. Every time you change this tube, you wiggle this wire all the way down under. Today, wow. Okay, Magic Eye wires are... They're perfect. They're good, but they're also quite stiff. So don't be moving this around too much. Did I get in with this and look at this gear close up? I think maybe I did. I did do that. Take a quick scan down the tuning capacitor. Any of the plates appear bent by accident or on purpose? No, and then there's that little one over here. The little guy. What's he doing there? And you know, that's it for on top. There's just nothing more to see up here. But it does have a bottom plate. Notice the bottom plate is missing most of its screws, which is a sign of somebody else being here. There's 2 screws here. Now this is one radio I would not rush to power up. Some radios I practically rush to get the power on them. Not this one. Now look at those green wires. Smokes. Come on, who did this? Need bigger screwdrivers, that's all. Now, any reason why I can't just lift this radio out? Oh, yes, I think so. So the bottom plate comes around the side, and look at it's yeah. I was gonna have a hard time getting this off with these screws in here. Holy smokes, man! Wow. I didn't eat my... I'm sure I had... I need my... you know what it is? I'm still halfway through my coffee cup. A cup of coffee. I need more coffee strength here. That one too. Somebody used a big screwdriver to put this in. My wife stunned me the other day when she said she wanted her turntable back. You know what? There's a good thing to get these with a screwdriver. A big honking screwdriver. Oh my gosh. She wants her turntable back, so I thought, well, I can't give her this one. It's messed up. So I didn't realize how expensive those things are. You can pay $100 for one of these. So basically I'm on radio silence on that issue now. Maybe it'll go away. Sometimes putting a project up on a turntable is really helpful, and other times it's actually a hindrance. What's happening here with this last screw? Now, okay, lifting this guy out. So about probably 60-70% of the weight of this whole thing is right here. So this is the thing to grab onto. And then I want to hold down the base plate, which is this. And kind of pull it up this way. You gotta plan these things. Look, this thing's big. It's heavy. It's a bit of a dangerous operation here. Moving the camera back, I give myself a little more space. So I'm going to try to lift it out of this bottom plate. I'm going to put the whole radio on the floor, and then I'm going to try to lift the chassis off the base with my feet on these things. And I got two hands free to lift it at that point, because I'm afraid what's going to happen. I'm going to get this up in the air. The base is going to come up with it. Then I'm going to have to push the base down while I'm lifting this up, and I won't last 15 seconds because this guy's heavy. Fail to plan? Plan to fail. Okay, down to the floor you go. Watch this exciting operation here. There it goes. No problem. Okay, what do we see? Fingerprints. Well, those are the fingerprints of one of the people who built this. All over the place there's fingerprints. Sooner or later mine will be in there too. Maybe there's a whole history there. You could study the fingerprints and maybe discover the 8 people who have had their hands on this thing. Okay, now I want to tip it to look underneath it. To flip it right over. Doesn't look too good with this radio because it's going to be coming down on top of here, on top of here. That's not bad, and on top of here. Or I stand it up on its end or on its back. Wow, this is a big radio. Let's go up on the end. We'll put the transformer low down here, and that should give some stability. At least we'll be able to get a look at it, even if we can't do much with it. Okay, so here we go. Now, may fall right over because it's so tall. Oh, it is. It's just going to go right over. So what I've got to do is I've got to support this gigantic mass of copper here with. This is not quite what I was hoping for. Blocks are all the same size here. It's the same size too. Okay, we're going to use this. Very, very stable. Very, very stable. Voila! What do we got here? We got space, we got parts, we got wires, we got coils. We've got lots of old capacitors. You got ones that look like they're electrolytic here, maybe not. All these, maybe not this. The big ones. Got dog bone resistors in here. Here's this certainly looks like a capacitor. There's something coming out the end of it. Down here we have a great big dog bone high wattage resistor, and we have more capacitors. These look like they've been put in after the fact. Some repair, some augmentation. So we have a long thing here. As you can see, wires connected all the way along it. Son of a gun, let me fix the camera there. You didn't see any of that. Let me start again. It's a long thing right along here. This is a cardboard cover, and it's riveted or screwed to the chassis. It's a huge resistor. That's like the biggest resistor I've seen like that. There's terminal, 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 terminal. One terminal not used. Look at the size of that thing. Wow. So that's going to be the high wattage resistor trying to throw its heat into the chassis. Look at this arrangement here. There's a fuse here. Come on. Okay, so this goes right into the power transformer. So 1, 2, 3, 4, 5 wires coming out of the power transformer. Is that all? That makes sense. There must be some more hidden under here somewhere. I haven't spotted. Okay. Great big honking wires. What's this guy? This is an outlet on the back. Yep. This comes in, comes around, and that's unusual. It's just under a screw terminal here. That's very unusual. So this outlet is hooked straight up to the wires coming in, which are not properly relieved. The fuse in here doesn't look right. So there's a fuse position here, but there's no. It looks almost like you'd snap in. That's really weird. You'd snap in a fuse with that's this long. It has a center terminal. I've never seen anything like that. This is open here. This fuse doesn't seem to be the correct size. You know what else? It looks like a 30 amp fuse in there. It looks like an automobile fuse. Oh, look at the size of the link in there. You can't really see it. Ooh, what is it? What are you doing in there? There's no words on it. There they are. You know what it says? Right on the end there? 30. 30 amp fuse? It's an automobile fuse. So we're going to leave it out for now because we don't know what it is. Oh, you know what it might be? It might just simply be... This might be done all wrong here. So these wires feeding this outlet may have wanted to pass through this fuse on the way, because here's a wire right here. That's probably the idea. It's a 30. It could be a 30 amp fuse, although it's not the right length for this outlet. 30 amp. Wait a cotton picking second here for it. Come on. My circuit breakers are 15, of course. Everything's 15. This just has to be wrong. So doing that's not a good idea either. Putting in a wrong fuse like that, and depending upon what it's trying to protect. There's some more really interesting parts right here. These, a whole bunch of them in here. 1A, 6A, 2A, 4A, 4A. Let's take a closer look at those. I can't say I've ever seen anything quite like that. I think they're just capacitors, but well, basically it's a capacitor, and you can see it. You can see how they've actually formed the capacitor inside this clear plastic housing. 1A, 5A, what's that mean? These are special capacitors built specifically for this radio, for this purpose. And the 2A doesn't tell you the value, it just tells you the when the guy goes to build a radio, he's supposed to put a 2A in there. And a 4A in here. I'm guessing away at this, of course. There you can see, here's another adjustment here. Another variable capacitor, I'm quite sure. So because this is inside of a sealed metal box, it's actually not in the worst of shape. Like, it's not covered in dirt. There's another one. So we got them up on top, we got them underneath. There's 1, 2, 3, now that I'm looking for them. Or are these the same thing as what's up on top? This is just them protruding down below. Don't think so. You know what? It is. That's exactly what it is. It's the same as what I saw on top. It's just a protrusion down under the chassis. So look at these beautiful coils. You know, this is the radio. Look how that's wrapped very carefully, very kind of a woven arrangement. What they're trying to do here, if I understand it correct, and like everything, I may have the story wrong. If you run a coil and you just bend all the wires around like this, and they're all in parallel, they have a fair bit of capacitive reactance with each other, especially like any two that are side by side like that. You can reduce it if you can somehow make the wires cross this way. Well, how can you wind a coil and have wires crossing this way? You cross them this way, and as you wind it, you do it in such a way that you end up with wires crossing at angles all the time. This will reduce the capacitance between turns. That's my understanding of what's going on with these coils. So these ones are just laid up flat, so they weren't concerned about, I could call it interwinding capacitance. Is that maybe I got it right? Just these two are fancy guys. These resistors. These resistors, they look a little bit unusual. Why have they got some white stuff on them? Let's get the close-up thing going again. Well, they don't look like other capacitors. Yeah, is this all the way back from, you know, is this original? But I'd be so stunned if it wasn't. Here's some more unusual looking ones here. Where's that a resistor? Body and dot. I'm not sure. Another one over here. I'm not completely sure what those are. that looks a little sloppy right there. That joint or connection, air-worn, but I think it's all original. Where's the band switch in here? Well, I'm looking right at it. Right here. Not sure what I would see. Oh, a little bang on that coil there. Ooh. Now when I look with my eye at the, what's actually down here. So of course on these coils, the facing outward side of them is capable of being, you know, hit with a tool or something, whack, something like that going on, or a soldering iron strike, or these are kind of right out there, these top ones. So it's worth looking at them, especially if you start having trouble, seeing if that's happened. Now, high wattage resistors. Let's just go through and see. You know what they're, yeah, I'll take that back. I was going to say there's not a lot of ordinary looking paper capacitors, but there are. Here's some kind of molded thing here. That could be a replacement. High wattage resistor here and one right here, almost in contact. You'd think they'd be spread just a little bit further apart. And I'm not working my camera very good today. Sorry about that. These two resistors I'm talking about. This capacitor looks replaced. So there's some components in here I'm not terribly familiar with. Augmenting the capacitors down here. Is that what these are? No, I don't think so. No, is this original? It doesn't look original up here. It looks like somebody's done that after the fact. So a lot of times to fight hum in a radio like this, you just add more capacitance in on these ones. That's what these are. I don't think so. This one is 8. This one is 15, I think is what it, no, 5. 0.5. This is 0.5. This is a small one. This is 8 and this is 0.5. Is this electrolytic? Seal tight paper capacitor. Well, I'll have to go with what it says. We'll see on the schematic, hopefully, if I can get a schematic for this guy. Okay, so, you know, generally speaking, of course, the radio's in good condition underneath. Nothing horrendous has happened to it. This must be the magic eye cable coming through here. Yeah, right in here. As for powering this guy up, continental condenser. Firing him up. Okay, there's a little weirdness here. So of course I don't have the cabinet, so I don't have the label for these controls. But this one, what is happening there? So there's a contact right here, and the contact just goes to ground. This all looks like it's been worked on. So that's grounded. That's not. Except it hits this little wire paper here. It can go either way. Oh, looks like it's broken. Looks like it's supposed to go here or here. That's it. Somehow we can go all the way. There's a trap that's come loose. Let me go back to the close-up camera. A little trap. So here it is. So it's supposed to go like this. See, it's hitting this little staple wire here. You go the other way, it's knocked the staple out. It's going right under it, and then it can go all the way over to here and do stupid things. You can see it's making contact there fairly nicely with whatever it is that this is for. What would this be for? Why would you have a switch which is grounded? What's it grounding? There's nothing hooked up to this switch. Shouldn't there be see where the solder is? Shouldn't there be a wire soldered on there that's broken off? If that's the case, it's hanging right here. It's hanging right here. Where? There's no... I don't see any free wire hanging here. Well, that's going to stay a mystery then. A grounding switch of unknown purpose. You can see the kind of shielded wire they're using. A spring shielded wire. Very common from back in this day. That's probably coming from the volume control. That one. Man, it looks really ugly up in here. They need to change the volume control? Doesn't look like it. Okay, so let's go through the controls then. So we know this one's all the tuning stuff. Band changer. What's this one? I don't know. Tone? Is there anything? What's it doing back here? So one lead is grounded, and the other one looks like it's going to this capacitor. That's on the outside. What's going on there? Middle one grounded, outside one going to a capacitor, and then there's nothing on the third terminal. It's a tone control. And we have a tone control. We have the mystery switch of nothing, and we have the volume control. What I think is the volume control because of the shielded wires. And this is interesting. This was on the other radio too. Yeah. So this shell is a capacitor. And the metal shell is shielding this capacitor. It's coming right off the volume control. Same thing done on the other radio, and I replaced this with just a regular airborne run-of-the-mill capacitor. And the other radio picked up a small hummy buzz on high volume. If you turn it way up, you could hear. I think it was probably because of what I did here. I might want to do this one a little better somehow. And maybe I could push out the old capacitor out of this tube and just slide in the new one, which I didn't bother doing on the other radio. There's some more of that green wire. See how critical it is to not touch it, not move it, because it would just fracture and come off. That's the that green wire goes inside this shielding. If you bend this shielding, you'll break the green wire insulation. Assumably it's just as deteriorated inside there. Now you could generate a short right in this cable and not even know it because it's all hidden. Don't bend things, that's the rule. Nothing to be bent. What are they doing down there? They're braiding wire. Why would they braid this? So it's coming a distance. It's coming a distance from not very much of a distance. Right. Oh no, there's some more. That's twisted, not braided. Well, that's a common thing to twist wires. It does go along. It goes all the way back to the power supply. So this is probably the B plus coming into the radio or something like that. I don't know offhand. Let's keep going here. Finding stuff. We have the two bases. Looks pretty normal. We have this thing here. So this is the this paper capacitor here. See how it's been done with this screw in this bracket, and then they've soldered it didn't really solder it to the chassis. They soldered a wire from the capacitor to the bracket. I don't think the bracket is soldered to the radio. Well, it's just possible that would be a problem. Bad contact. Airborne connection. So they're into the airborne connections in this radio. There's one here, another one in here. It sounds like that was a standard practice. Here's another one here. Okay. Well, once again, if we look at these capacitors here, which are, especially this one, this just doesn't look right. This looks too new. We come up, and you can see, definitely, I think this is a definite sign of a replacement here. One or all of them got replaced. These don't look replaced. That one does, though. So I think it's safe to say a little bit of work's been done. What is this now? This is a Solar manufacturing company. Outside foil, tight to the chassis there, I think. It's just another. So I've turned the camera sideways to make the print come up vertically, and this makes it almost impossible for me to move it around. I gotta turn it back the right way, so my hand movements make sense on the screen. Good. It's another. A lot of capacitors soldered straight down to the chassis. That's a tough go. Yeah, lots of soldering right to the chassis. There's a nice job. Now see that? That's a nice job. You gotta wonder, is that really how it came out of the factory? It looks like a cold yeah, it says, oh. Okay, I don't know what I saw there. Never mind. Look at this. This resistor's a little unusual too, because it has this white stuff. Some unusual parts in here. Big dog bone. Okay, on the theory that the longer you look, the more you see. But I think I'm reaching the end of the look time. There's lots of those. Probably, maybe they were expensive to manufacture or something with this different materials here. I don't know. Who knows? I haven't seen too many look like that. Now, did I really go down through this part? This is the rectifier tube area. Yeah, look at this. Look at this fancy capacitor. Wow, you gotta be proud of your capacitors. Look at that thing. Solar? Buller. Another letter on that. Tubular. Tubular. Condenser. Well, condenser is a pretty old term, you know. Does it say line on it? Is this a special one for going across the power line? Can't quite read what it says there. Something voltage, something 00 line. I don't know. Well, it could be. It could be this is a special capacitor in the sense that it's more suitable for going right across the power line. Less likely to catch fire. I don't know, this is such an old radio. Did they even do that back then? There's that mile-long resistor down here. I assume it's one long resistor. Maybe it's two. So how do they handle that black wire coming out of that capacitor? Looks like there's a solder terminal. Awkward to get at down in there. Square plate riveted onto the radio. There's another plate, but this one, see, this one's insulated. That dark material is insulated, so this capacitor, the outside shell of it is probably not, almost certainly not at chassis potential. Gotta watch out for these things. Okay, I think my head is full on this radio here. Now, how to approach this? The owner didn't whisper to me whether he thinks it works or not. Chances are this is a working radio right now. We've got to sort out this fuse issue here. I suspect if I leave the fuse out, all I've done is nothing, I think. Definitely a strange arrangement here. Wires coming out of the transformer. These must be going to the transformer. And they get their power. One will get its power from here. The other one's going to go up to the switch and come back from the switch, and there it goes in. So this is so the fuse has to be in there. You have to have a fuse between here to get power to the transformer. So this is the transformer fuse. 30 amps. Well, we're going to fix that. Put the right size fuse in, because that's not going to protect anything. That wouldn't protect anything in my house. Okay, I think so. I see I got 3 minutes left if I want to make a 1 hour video, which I like it when my videos come out to 1 hour. What's the approach here? I think what I might want to do, rather than rush into trying to fire this guy up, is test the tubes first. And then I don't have the speaker that came with it. So without the speaker, we could turn this guy on, and all that would happen is basically the tubes would light up, and the power supply would generate a voltage, but it wouldn't get through the radio. We do a partial startup and see what happens then. And then I probably can, I'm going to have to really look into this, plug the speaker that's in the other Westinghouse radio, right, this radio, just take it out of there and just plug it right into this one. You know what, I can't do that because this isn't push-pull. I don't think it's push-pull. A 6L6, yeah, I don't think it's push-pull. So that might make things a little easier. That means there should only be 4 wires going to the speaker. So there's the speaker thing, right down here. Right down here. This is the speaker thing? Yeah. Right down there. What do we get out of that? So I see 1 wire. I see this is tied around to this other pin here. So 2 pins fed from 1 wire. So 1 wire here. It's coming right from this filter capacitor. There's another wire on it going over to the rectifier tube. And I just can't really see clearly what's going on up in there. I think you gotta have 2 tubes. I don't think a 6L6 is a 2 tube in 1 tube. I don't think you can do push-pull. Oh, that's for lamp only, and look at the unusual plug there. Wow, I've almost never seen one of these. Oh, there's a whole bunch more adjustments I had missed up until this point. And these are, oh yeah, right there, coming right through slug-tuned coils. So we'll have to resolve the speaker situation, but it might be fairly simple. I might be able to do something simple here to get a speaker onto it. The real challenge is the missing field coil. Schematic, gotta get a schematic. Yeah, okay, that's the order of business. Test all these tubes. Find out what's going on with all these tubes here before doing anything more. And then, after that, decide what more to do. Great, thanks a lot for watching. I hope you enjoyed this. I enjoy this process of checking stuff out like this. It's one of the, it's pretty easy on the brain. The rest of it gets more and more difficult as I go. So, great, thanks a lot for watching. And I'm going outside for most of today because it's almost like summer up here. It's 18 degrees today, when normally it should be 4 or 5, something like that. 18 degrees, wow. So thanks a lot for watching, and I hope you enjoy your day too.